Every single time you type a website name into your browser, something incredible happens. Something you probably never even think about. In a fraction of a second, an invisible, global system kicks into high gear, making sure your request goes exactly where it needs to. Without it, the internet as we know it would simply cease to exist. Many of us just assume the internet knows where Google or YouTube lives. We type the address, and poof, there it is. Like magic. But it's not magic at all. It's an incredibly sophisticated, distributed directory that works tirelessly in the background, 24 hours a day, 7 days a week. So, how does this digital wizardry actually work? How does your computer, a collection of circuits and silicon, magically understand what Google.com means? We're about to pull back the curtain on the domain name system, or DNS, the unsung hero that keeps the entire internet online. Let's break down this fundamental technology. And here's where it gets interesting. Imagine trying to call your friend, but instead of using their name, you had to remember their phone's serial number. It would be impossible, right? Our brains are wired for names and words, not long strings of numbers. The internet, however, speaks in numbers. Every device connected to the internet, from your smartphone to a massive web server, has a unique numerical address called an IP address. Think of it like a street address for a house. Your browser needs that specific address to send information to the right server. So, we have a problem. Humans want to use easy-to-remember domain names like Amazon.com, but computers need IP addresses like 172.217.160.142. DNS is the brilliant solution to this exact problem. It acts as the ultimate translator, connecting our human-readable requests to the machine-readable locations. It's like the world's biggest, fastest phone book, constantly being updated. But the genius part is this: the DNS phone book isn't just one giant book sitting on a single shelf. That would be slow and prone to failure. Instead, it's a massive, distributed hierarchy, like a global library system with different levels of specialized librarians. At the very top, we have the root name servers. These are like the main library directory, pointing to where you can find general categories of books. There are 13 logical root servers, distributed physically around the world for robustness. They don't know the exact IP address for Google.com, but they know where to send you for all .com websites. Below the roots are the top-level domain, or TLD, name servers. These are like the specific sections in our library, the .com section, the .org section, the .net section, or even country-specific ones like .uk or .jp. A TLD server knows which authoritative server is responsible for a specific domain name within its TLD. Finally, we have the authoritative name servers. These are the experts for a particular website. If you're looking for bytesize.tech, the authoritative server for bytesize.tech has the definitive answer, the exact IP address for that website. It's like the specific bookshelf in the .tech section that holds the bytesize book. This layered approach makes the system incredibly resilient and efficient. Now, let's put it all together and trace the journey of a single DNS query. When you type ourwebsite.com into your browser and hit enter, here's the whirlwind trip that happens. First, your computer checks its own local DNS cache. Has it looked up ourwebsite.com recently? If so, great. It uses the cached IP address and your browser connects directly. That's super fast, like remembering a friend's phone number without looking it up again. If not, your computer asks your local DNS resolver, which is usually provided by your internet service provider, or ISP. This resolver is like your personal assistant, tasked with finding that IP address for you. Your ISP's resolver then begins its own journey. 1. It asks a root server, "Hey, where can I find the .com TLD server?" The root server replies with the address of the .com TLD server. 2. The resolver then asks the .com TLD server, "Okay, where can I find the authoritative server for ourwebsite.com?" The TLD server responds with that specific server's address. 3. Finally, the resolver asks the authoritative server for ourwebsite.com, What's the IP address for our website.com? The authoritative server provides the exact IP address. Once your ISP's resolver gets that IP address, it sends it back to your computer. Your computer then tells your browser, and your browser can finally connect to our website.com using its IP address. This entire process, from your browser to multiple servers and back, often takes mere milliseconds. It's a testament to the internet's incredible engineering. This whole process sounds like a lot of steps, right? How does it happen so fast? The secret weapon is caching. Every step of the way, your computer, your ISP's resolver, even some of the TLD servers, they all remember previous answers. When your ISP's resolver looks up google.com for the first time, it stores that IP address for a certain period. The next time anyone on that ISP asks for google.com, the resolver just provides the cached answer immediately, skipping the entire multi-step lookup process. This makes the internet feel lightning fast, dramatically reducing latency. It's like a librarian remembering the exact shelf for a popular book, instead of having to look it up in the main directory every single time. But what about security? What if someone tampers with the phone book and redirects you to a malicious website instead of the real one? That's where Dnssec, or Domain Name System Security Extensions, comes in. Dnssec adds digital signatures to DNS data, ensuring that the information you receive hasn't been tampered with. It's like having a tamper-proof seal on every entry in our internet phone book. While not universally adopted yet, its importance for internet security is growing, giving us more confidence that when we type ourbanking.com, we're actually going to our bank. Even with all this brilliant engineering, sometimes things go wrong. Because DNS is so fundamental, when it breaks, it feels like the entire internet is down. Have you ever tried to go to a website and gotten an error like server not found or this site can't be reached? Often, the culprit is DNS. Imagine you're trying to call a friend, but their number changed, or you wrote it down wrong. The call won't go through. It's the same with DNS. One common issue is a typo in the domain name itself. Just one letter off, and DNS won't know where to send you. Another is an expired domain. If a website owner forgets to renew their domain, it simply disappears from the DNS phone book. Or, sometimes, the authoritative DNS server for a website might be down or misconfigured, meaning no one can get the correct IP address. And sometimes, your local ISP's DNS resolver might be having issues, preventing it from doing its job correctly. Troubleshooting DNS often starts with simple steps, double-checking the URL, clearing your browser's cache, or even restarting your router. If you suspect an ISP-level DNS problem, you can sometimes switch to public DNS resolvers like Google DNS or Cloudflare DNS, which offer more reliable and often faster service. Understanding these common pitfalls helps us debug why our internet might be acting up. So, we've talked about how DNS translates names to IPs and how Dnssec adds a layer of integrity. But there's another crucial aspect: privacy. Traditionally, your DNS queries, asking for an IP address, were sent in plain text. This meant that anyone on your network path, like your ISP, could see every website you were trying to visit. It was like shouting your phone number requests across a crowded room. And here's where we look to the future with advancements like DNS over HTTPS, or DO, and DNS over TLS, or DOT. These technologies encrypt your DNS queries. Instead of sending them in plain text, they're wrapped in the same secure connections that protect your online banking and sensitive data. This is a huge step forward for privacy. It means your browsing activity is much harder for third parties to snoop on. While it adds a tiny bit of overhead, the security and privacy benefits are substantial. Many modern browsers and operating systems now support DO or DOT, and enabling them is a simple way to take more control over your online privacy. It's moving from shouting your request to whispering it securely, ensuring only the intended recipient hears. So, there you have it. The Domain Name System, or DNS, is far more than just a technical detail. It's the foundational directory service that makes the internet navigable for all of us. Without it, we'd be lost in a sea of numbers, unable to find anything. We've learned how domain names are our friendly labels, while IP addresses are the actual destinations. We've traced a DNS query's journey through root, TLD, and authoritative servers, a global, distributed network working in perfect harmony. We saw how caching makes everything incredibly fast, and how Dnssec, DO, and DOT are continuously improving the security and privacy of our internet experience. Next time you type a website into your browser, take a moment to appreciate the silent, tireless work of DNS, the invisible phone book that keeps the entire world connected. Understanding how it works empowers you to better understand and even troubleshoot the internet around you. If you found this breakdown insightful, make sure to hit that like button and subscribe. And for more deep dives into the plumbing of the internet, check out our full playlist on networking and infrastructure. Next, we'll explore how information reaches you faster with CDNs and caching. You won't want to miss it.